Okay, here's a reaction that's just kind of helping us remember the differences between reactions that look similar. And so here we are, we have two similar situations. I've got two benzene rings that are happening with my reactants, and I have bromine Br2 as a common reagent in both of the reagent platforms. And so I'm going to actually end up with products that are quite similar looking. So they're going to have a benzene ring, and they're going to have that benzene ring attached to ethyl group. And the only difference is what's happening with the other stuff there. Now, the first one is the addition to Br2, and that means I'm gonna add both bromines across the double bond. What I need to remember is that the bromines add anti from each other. And so now the thing with this one is that, yeah, even though the bromines add anti from each other, I'm going to actually have there's not actually a stereocenter. So I don't typically have to show that, but I just want to remind you, the reader, that in fact the bromines do add anti from each other. And if there was a deuterium, if one of these hydrogens was a deuterium, it would definitely matter at that point. Okay, the next thing is the water. I'm going to still have a bromine that's going to add. And again, I'm going to go ahead and just to remind everybody, I'm going to show this as a wedged and dashed representation, even though it's not a stereo center. Just to remind you that the alcohol is going to add both, excuse me, not anti-mercaptan, but it's going to be an anti-addition. So that means the alcohol is up compared to the bromine. And it's also Markovnikov. Now, again, if the hydrogen were a deuterium, then this would be a stereocenter. So it would be important to show the difference in the bromine and the OH. But again, it's not a stereocenter, so it's not. And so we can even remind ourselves that the other possibility, the reverse possibility, would be possible if they were stereocenters, but of course they're not. So in this particular case, it doesn't matter. But as soon as I change this to a deuterium, it absolutely does matter. And so what I mean is that I'm going to get the other possible stereo configuration. And most of the time that does mean enantiomer, but sometimes, remember, it could be a diastereomer if there are other stereocenters in the reactant. And so that's all that I wanted to show you with this reaction. So just to kind of keep in mind the regioselective and stereoselective outcome of these reactions.